All right, let's look at the Taylor polynomial. Right, Taylor polynomial is just the first part of the Taylor series. So instead of including all infinitely many terms, we're going to only keep the term up to the nth power. So we call it the nth degree Taylor polynomial. Right, so you can see that this is exactly the same formula for a Taylor polynomial. But you can see that it doesn't go to infinity. It actually only stops at nth power. All right. So let's try to find the Taylor polynomial for a particular function. All right. Let's look at this following example. All right. Let's find the fourth degree Taylor polynomial for square root of x at the center x equals 1 or a equals 1. All right, so let's do that. All right, so we just need to compute a bunch of derivatives. So first we have f of x. All right, I'm going to write the square root of x as x to the 1/2 power because it's easier to take the derivative. Then, so we know that if you plug in the center, in this case 1, it's going to be 1, square root of 1 is 1. So I'm going to just put 1. All right, and the first derivative, f prime of x, is equal to 1/2 x to the, right, subtract 1, so it's a negative 1/2, right? And if you plug in 1, you're going to get, of course, 1/2, right? And the second derivative, f double prime of x, is going to be equal to 1/2 times negative 1/2, negative 1/4, x to the negative 3/2. Right, so this then if you plug in x equal 1 at the center, it's going to be negative 1/4. Right, and the third derivative, so f triple prime of x is equal to, right, so this is going to be positive 3/8 x to the negative 5/2. And if you evaluate that, so triple prime of 1, you're going to get 3/8. Right, then last one, we need the fourth derivative of x. So this is going to be negative. All right, 3 times 5 is 15. 8 times 2 is 16. X to the negative 7/2. Right, then if you evaluate that, so it's a fourth derivative of f evaluated at 1 is going to be negative 15/16. All right, so let's construct the fourth degree Taylor polynomial. All right, so s of 4 of x is equal to, all right, first term is 1. Second term is 1/2 times x minus center is 1. All right, next one is negative 1/4. Then you have x minus 1 squared. Then you would have to divide by 2 factorial. All right, and next one is 3/8. So you have a 3/8. Then you have a quantity x minus 1 cubed, then divide by 3 factorial. All right, last one is negative 15/16, x minus 1 to the 4th power, divide by 4 factorial. All right, so this is the Taylor polynomial of degree 4 for square root of x. All right, so let's try to see how, let's try to compare the graph of this Taylor polynomial and the graph of the original function as square root of x. Right? So I open up a GeoGebra here. Right? I'm going to sketch, so I'm going to write the f of x is equal to sqrt square root of x, then hit enter. Right? You see that this is the original graph. Right? So let's try to write my Taylor polynomial. So f sub 4. Right? Actually, I'm going to introduce the a command of GeoGebra to find the Taylor polynomial. You can just spell Taylor. All right, so there's a suggestions here. So function is f, so center is 1, and order is, we want S4, so order is 4. So if you hit enter, right? So this is exactly the same same function that we found. So this is S4. All right, but you can see that the S4 is this orange curve right here, right? So the center is at 1, so I'm going to put 1, comma 1. All right, so this is the center, right? Then you can see that near the center, this approximation, which is the Taylor polynomial of degree 4, is very close to each other. You can see that you can't really tell the difference between the orange one and the blue curve, right? But as you can see that if you go far away from the center, and you can see that this is a little bit different, right? But the Taylor polynomial is very, very close to the original function near the center, right? And if you increase the degree, if you include more terms, and then you can you see that this orange curve is going to be getting closer to the blue curve. Right? But anyway, you can see that these Taylor polynomial approximates the original function very, very well near the center. All right? So that's it. I hope that this was clear.